Hi, my name is Alex Sawatzka, and this is Lab 2, Line of Charges. The purpose of this lab is to distribute a charge evenly across the length of the tape in a computational model, and to estimate the amount of charge on each tape necessary to float above each other. The formulas we're using in this lab are the electric force, the magnitude of the electric force, the electric field, the equation for the force of gravity, and the fact that the force of gravity and the force of the electric field is equal, and then the constants we're using are Coulomb's constant and then the constant of the value of an electron, the charge of an electron. And the results that we got from this lab were that the value of the electric force was 0.00196 newtons, and the charge of each tape was 3.19 times 10 to the negative 8. In this lab, we're going to ignore the air resistance between the tape charges because the results would be negligent. The system is also the pieces of the charged tape. We're also going to assume uniform and equal charges between the two pieces of tape, although this might not necessarily be the case. We're also going to be treating the tape as a line charge instead of a point charge as we did in the previous lab. And then possible sources of error in this lab could be the assumptions that we're making above and human error. For the data and calculations of this lab, we start with calculating the mass of the tape, which was 0.0002 kilograms using the length of the tape, and then the distance that we calculated previously at 0.43 meters, and then the net charge of the tape that we also calculated previously. And then we calculated the force of gravity using negative mg and got a value of 0.00196 newtons, and carrying that over to equal force the electric field, and we solved for Q using that equation and ended up getting 3.19 times 10 to the negative 8 coulombs. For this closed script model, we had to create the electric field, including the charge, the observation location, and the position, and then calculate the electric field using the K value, the Q, the magnitude, and then return that value. Then we created the line charge using the axis and the position, and then also just calculating the magnitude of each point charge and the mass of the point charge. Then we calculated the net electric force on the top tape and then the bottom tape. Then created arrows to represent each of these forces, the white arrow being the force of the electric field, the yellow arrow being the force of gravity, and seeing that there's no acceleration, these two forces cancel out. The green arrows are the electric field from each point, and we sum these values up to get the value of the line charge. For the conclusion of this lab, we asked what would happen if we modeled each of our tapes as a single point charge like in the previous lab, and to compare these estimated values. Doing this, we get that the estimated charge of the single point charge was 6.35 times 10 to the negative 8, and that this value was larger than the estimated charge of the line charge of 3.19 times 10 to the negative 8. Then we ask, why do these estimates differ? They differ because we are adding up each individual charge rather than looking at a single point charge, and this means that the value of the line charge would be more accurate since we are looking at each different point charge together. Thank you for listening.